Welcome to our journey into the fascinating world of machine learning. At its core, machine learning is all about teaching computers to learn from data, rather than following strict step-by-step instructions. Instead of programming every single rule, we let the computer analyze patterns and make its own decisions. This approach has revolutionized how we solve problems, from recognizing faces in photos to recommending your next favorite song. In this video, we'll explore the key concepts, types, and real-world applications of machine learning, breaking down complex ideas into easy-to-understand scenes. Let's get started by understanding what makes machine learning so unique. Like traditional programming, where every rule is coded by hand, machine learning systems use data to figure out how to perform tasks. Imagine giving a computer thousands of photos of cats and dogs. Instead of telling it exactly what a cat or dog looks like, you let the machine find patterns in the images. Over time, it learns to distinguish between the two on its own. This ability to learn from data is what sets machine learning apart and makes it so powerful in today's digital world. The heart of machine learning are algorithms, step-by-step procedures that process data and uncover patterns. These algorithms can be simple, like finding the average of numbers, or complex, like recognizing speech or translating languages. The choice of algorithm depends on the problem you want to solve and the type of data you have. As we move forward, we'll see how different algorithms are used for different tasks, making machine learning incredibly versatile. Model in machine learning is like a mathematical blueprint that represents what the algorithm has learned from the data. Think of it as a recipe that helps the computer make predictions or decisions. Once trained, a model can analyze new data and provide answers, whether it's identifying objects in a photo or predicting tomorrow's weather. Models are central to how machine learning systems operate and improve over time. One of the most common types of machine learning is supervised learning. In this approach, the computer is given labeled data, meaning each example comes with the correct answer. For instance, if you want a machine to recognize handwritten numbers, you provide it with thousands of images, each labeled with the correct digit. The algorithm learns from these examples and can then predict the label for new, unseen images. Supervised learning is widely used in tasks like email spam detection and medical diagnosis. Supervised learning is a bit different. Here, the computer is given data without any labels or correct answers. The goal is to find hidden patterns or groupings within the data. For example, a retailer might use unsupervised learning to segment customers into different groups based on their shopping habits. This helps businesses understand their customers better and tailor their services. Unsupervised learning is great for discovering insights in large, unstructured datasets. Reinforcement learning is inspired by how humans and animals learn from experience. In this approach, the computer learns by trial and error, receiving rewards or penalties for its actions. Over time, it figures out the best strategies to achieve its goals. This type of learning is used in game-playing AI, robotics, and even self-driving cars. Reinforcement learning allows machines to adapt and improve their behavior in dynamic environment. There are many algorithms in machine learning, each suited for different tasks. Some popular ones include decision trees, which split data into branches to make decisions, neural networks, which mimic the human brain, and support vector machines, which find the best boundaries between categories. Understanding these algorithms helps us choose the right tool for the job and build effective machine learning systems. Decision trees are a simple yet powerful algorithm. They work by asking a series of questions about the data, splitting it into branches based on the answers. Each branch leads to a decision or prediction. For example, a decision tree might help a bank decide whether to approve a loan by considering factors like income and credit history. Their straightforward structure makes them easy to understand and interpret. Neural networks are inspired by the human brain and are especially good at handling complex tasks like image and speech recognition. They consist of layers of interconnected nodes, or neurons, that process information in stages. As data passes through the network, it's transformed and refined, allowing the system to learn intricate patterns. Neural networks power many modern AI applications, from voice assistants to self-driving cars. Support vector machines, or SVMs, are another popular algorithm. They work by finding the best boundary that separates different categories in the data. Imagine drawing a line that divides cats from dogs in a scatter plot of features. SVMs are especially useful for classification tasks and can handle both linear and nonlinear data. Their ability to create clear boundaries makes them valuable in many applications. Training a machine learning model involves feeding it data and allowing it to learn the underlying patterns. The process starts with a dataset, which is split into training and testing parts. The model uses the training data to learn, and then its performance is evaluated on the testing data. This helps ensure the model can make accurate predictions on new, unseen information. After training, it's important to test and validate the model. This step checks how well the model performs on new data it hasn't seen before. Validation helps catch problems like overfitting, where a model memorizes the training data but struggles with new examples. By carefully testing and validating, we build models that are reliable and robust in real-world situations. Overfitting happens when a model learns the training data too well, including its noise and outliers. As a result, it performs poorly on new data. Imagine memorizing answers for a test instead of understanding the concepts. You might do well on practice questions but struggle with new ones. Preventing overfitting is crucial for building models that generalize well. Underfitting is the opposite problem. Here, the model is too simple to capture the underlying patterns in the data. It performs poorly on both training and new data. Think of it as trying to fit a straight line to a complex curve. You miss important details. Balancing model complexity is key to achieving good performance. Feature engineering is the process of selecting and transforming the right pieces of data or features to help the model learn better. Good features make it easier for algorithms to find patterns and make accurate predictions. This step often involves creativity and domain knowledge, as the right features can make a big difference in model performance. For training a model, data must be cleaned and prepared. This process, called data preprocessing, includes handling missing values, removing duplicates, and scaling features. Clean, well-prepared data leads to better models and more reliable results. Skipping this step can cause problems down the line, so it's a crucial part of any machine learning project. Judge how well a model is performing. We use evaluation metrics. These are numbers that summarize the model's accuracy, precision, recall, and other qualities. The choice of metric depends on the problem. For example, in medical diagnosis, recall might be more important than precision. Using the right metrics helps us understand a model's strengths and weaknesses. Classification is a common machine learning task where the goal is to assign items to categories. For example, sorting emails into spam or not spam, or identifying whether an image contains a cat or a dog. Classification models learn from labeled examples and can handle a wide range of real-world problems. Regression is another important task where the goal is to predict a continuous value. For example, estimating house prices based on features like size and location, or forecasting stock prices. Regression models learn the relationship between input features and the target value, making them useful for many prediction problems. Clustering is an unsupervised learning task where the goal is to group similar items together. For example, segmenting customers based on shopping behavior or organizing documents by topic. Clustering helps uncover hidden structures in data and is widely used in marketing, biology, and more. Dimensionality reduction techniques help simplify complex datasets by reducing the number of features while preserving important information. This makes models faster and easier to interpret. Principal component analysis (PCA) is a popular method, often used to visualize high-dimensional data in 2 or 3 dimensions. Ensemble methods combine multiple models to improve performance. By averaging or voting on predictions, ensembles often achieve better results than any single model. Techniques like random forests and gradient boosting are widely used in competitions and real-world applications, offering robustness and accuracy. Deep learning is a subset of machine learning that uses large neural networks with many layers. These deep networks can learn complex patterns from massive amounts of data, making them ideal for tasks like image recognition, natural language processing, and more. Deep learning has driven many recent advances in AI. Natural language processing, or NLP, is a field of machine learning focused on understanding and generating human language. Applications include chatbots, translation services, and sentiment analysis. NLP combines linguistics and machine learning to help computers interact with people in natural, meaningful ways. Computer vision is another exciting area where machines learn to interpret and understand visual information from the world. From facial recognition to self-driving cars, computer vision systems rely on machine learning to process images and videos, making sense of complex visual data. Speech recognition technology allows computers to understand and process spoken language. Machine learning models are trained on vast amounts of audio data, enabling applications like virtual assistants and voice-controlled devices. This technology is making human-computer interaction more natural and accessible. Recommendation systems use machine learning to suggest products, movies, or music based on your preferences. By analyzing your past behavior and comparing it to others, these systems provide personalized recommendations, making it easier to discover new favorites. Fraud detection systems use machine learning to spot unusual patterns that might indicate fraudulent activity. By continuously learning from new data, these systems can quickly adapt to new tactics used by fraudsters, helping protect businesses and consumers. Machine learning is transforming healthcare by helping doctors diagnose diseases, predict patient outcomes, and personalize treatments. Models can analyze medical images, patient records, and genetic data to provide insights that improve care and save lives. Self-driving cars rely on machine learning to navigate roads, recognize objects, and make split-second decisions. By processing data from cameras, sensors, and maps, these vehicles can safely transport passengers without human intervention, showcasing the power of AI in real-world environments. Robots equipped with machine learning can perform complex tasks, adapt to new situations, and even learn from experience. From manufacturing to home assistance, machine learning is enabling smarter, more flexible robots that can work alongside humans. In finance, machine learning models analyze market data to predict trends, manage risk, and automate trading. These systems can process vast amounts of information quickly, helping investors make better decisions and respond to market changes in real time. Marketers use machine learning to analyze customer data, segment audiences, and personalize messages. By understanding what customers want, businesses can create targeted campaigns that increase engagement and drive sales. Despite its power, machine learning faces challenges like biased data, privacy concerns, and the need for large datasets. Addressing these issues is essential for building fair, ethical, and effective systems that benefit everyone. Ethical considerations are crucial in machine learning. Models can unintentionally reinforce biases present in the data, leading to unfair outcomes. Developers must carefully evaluate their systems to ensure they are fair, transparent, and accountable. Protecting user privacy and securing data are top priorities in machine learning. Sensitive information must be handled responsibly, and systems should be designed to prevent unauthorized access or misuse. Strong privacy and security practices build trust and safeguard users. Big data fuels machine learning by providing the vast amounts of information needed to train powerful models. As more data becomes available, machine learning systems can learn more complex patterns and make better predictions, driving innovation across industries. Cloud computing has made machine learning more accessible by providing scalable resources for training and deploying models. With cloud platforms, even small teams can leverage powerful computing infrastructure, accelerating research and development. The machine learning community benefits from a wealth of open-source tools and libraries. Frameworks like TensorFlow, PyTorch, and Scikit-learn make it easier to build, train, and deploy models, fostering collaboration and innovation worldwide. Machine learning models can continue to learn and improve as new data becomes available. This process, known as continuous learning, allows systems to adapt to changing environments and stay relevant over time, making them more effective in the long run. In many applications, humans work alongside machine learning systems to provide feedback, correct errors, and guide learning. This collaboration, known as human-in-the-loop, combines the strengths of both people and machines for better outcomes. The future of machine learning is bright, with new breakthroughs happening every day. As algorithms become more advanced and data more abundant, we can expect even smarter systems that solve bigger challenges, from climate change to personalized medicine. If you're interested in learning more about machine learning, there are plenty of resources available. Online courses, tutorials, and open datasets make it easier than ever to get started. Whether you're a beginner or an expert, there's always something new to discover in this exciting field. To wrap up, machine learning is transforming the way we interact with technology and solve problems. By enabling computers to learn from data, we unlock new possibilities across industries and everyday life. As you continue exploring, remember that machine learning is a journey, one filled with challenges, discoveries, and endless opportunities.